Hi.
Hi guys, I'm going to do most of the talking because Miss Beller's just not feeling well, as you know if you have her. Now quickly, this is actually more on logarithmic functions. The actual title to this section, it's an appendix, it's an extra section, is logarithmic functions to other bases, but really this is a little bit more of the same stuff that we're doing, but we just want to do a few more problems. Okay? All right, so let's remember the important thing that you were supposed to get from the last class activity that we did is that logarithm and exponential functions are inverses of each other. And so we can use the properties that exponents have to work logs and vice versa. So make very sure that you pay attention when it says to use a calculator or not to use a calculator, because that's how these will be separated on quizzes and tests. Okay, so log base 5 of 125. That means 5 to what power? So if we make that equal to x, that means 5 to what power gives us 125. What we want to do, and this is really key, is write these numbers as the same base, and 5 to the 125, 5 to the third is 125. So now what we have is an equation with the bases equal, and if the bases are equal, the exponents are equal. And that is how you do that. We did several of those in the last class activity. All right, this one is 1/2 to the x equals 32. Now we need to look at the relationship between 1/2 and 32. Let's start with 1/2. 1/2 is 2 to the negative 1, and that's still being raised to the x. Now we see that base of 2 there, and what can we do with 32? Well, 32 can be written as 2 to the 5th. And let's go back to the left side. Recognize that 2 to the negative 1 to the x, we multiply the exponents, is 2 to the negative x, and 2 to the negative x equals 5, so negative x equals 5, and we don't want to solve for negative x, we want to solve for x, so multiply both sides by negative. Simple algebra 1. Okay, so if we set this one equal to, logarithm is our exponent, so 4 to what power gives negative 64. And as you can see, you should recognize very immediately that the answer is no solution. Why? Because 4 is a positive number. You cannot raise a positive number to any power and get negative. So that's as much as you can do. Okay. All right, now, once again, here we have a logarithm equation. Let's remember the saying that a logarithm, log is exponent. If you will remember log is exponent, that will help you solve all these problems, because we read the mathematical sentence as logarithm is the exponent. So our exponent is 2, and the base, the thing that's hanging down there, is 6. So 6 squared is x, makes it x 36. And we can also use the ear thing. So x is 36. A very important part of doing these problems is paying attention to the domain. Remember that in this case we have our variable right there as our argument, and we have to know that x has to be positive. Okay? Positive, not equal to 0. It's just greater than 0. And we did find an answer greater than 0. Okay, let's go over here to b. All right, this becomes, again, writing this as an exponential function, 4 to the x equals 1, and you should know without even thinking by now that x has to be 0. All right, let's go to letter C. This is 1/5 to the x equals negative 10. Well, guys, can you raise, look at 1/5. 1/5 is a positive number. You cannot raise a positive to any power and get negative, so you're done.
Notice you can't have a negative in a logarithm either. So this, would already tell you there's no solution.
Okay. Now, 7 to the x equals 7. Now what does that understood exponent on 7 there? It's 1, so that has to be a 1. See how simple these are? They're not too terrible. All right, now let's take this logarithm equation. Our logarithm is an exponent rule, tells us 2 is the exponent on the base of 5, and that is equal to x plus 2. We know that 5 squared is 25 equals x plus 2, and so we get x to be 23. Now let's go back. Before we start a problem like this, we want to look at our domain, and we should really do that first. So our domain, x plus 2, has to be positive, so x must be greater than negative 2, and if we look at our answer, it satisfied it. Remember, we want to actually start with domain all the time. Now, if you can please go to the textbook 5.5a, and I've given you the page numbers there, and work those problems. That seems like a lot, but they take almost no time at all. You should be done in less than 5 minutes with those problems. All right, now we're going to go ahead and show you how to do these problems here with a change of base, because you may at some point be using a calculator that's not our wonderful TI Inspire CAS, where you have to change the base because it doesn't allow you to stick in a different base. And this is how you do it. If we have a base that's, remember that the LOG is understood to be base 10 and LN is base E, so if you ever needed to work with a different base, say base 5, then you can use, the easiest thing is to use this one here, because natural log doesn't require you to put anything in a regular calculator. So if I am looking at log of base 6 of 8, that we could do as ln of 8 over ln of 6. Or you could also do that as log of 8 over log of 6. Either way, you get the same answer, and that's 1.160558 blah blah blah, and we would round that to 1.161 or 1 point, that's rounded, and truncated with 1.160. Now what this means, guys, is that 6 to that power, so 6 to the 1.161 is going to be 8. That's what that's telling you. Okay, why? Because a logarithm is an exponent. So this is what exponent on the base of 6 would give us the number 8. All right, so real quickly to calculate the next one, we would write this. Easiest way is natural log of 5 over natural log of 9. And you do your calculation and you get 0.73249, so 0.732. And once again, what that means is that 9 to the 0.732 is going to give you 5. And that makes sense because, you know, 9 to the 1 is 9. So 9 to a decimal is going to give you something less than 9. Okay? Now, the last one.
The square root of 9 is 3, and that's 0.5. So, because half, that's bigger, so.
Yeah, so we expect it to be a number bigger than 3 because 0.7 is bigger than 0.5. All right, ln 7 over ln 5. And that's about 1.20906. Okay, once again, it just means that 5 to the about 1.209 should give you 7. Now, the reason we actually wanted to show you this is, number one, in case you have to use a calculator that doesn't allow you to enter a different base. But remember way back ago what we did is if we had the natural log of A times A over B, natural log of A over B, no, natural log of A over B, yeah. Natural log of A over B. That is not equal to natural log of A over natural log of B. And that, because what would natural log of A over natural log of B do? It's going to do this. It's going to change a base for you. So you want to be super, super careful. Okay? Okay, natural log of, yeah, natural log base B of A is natural log of A over B.
These are equivalent, these are not.
Yes, so make sure you don't make that mistake. And here's your second set of problems. And you know what to do. We don't need to read this. It's the same rules every time. Have a great day, and don't forget you have another video to watch.